My name is David Fukuda. I'm an associate professor in the School of Kinesiology and Physical Therapy, and I'm happy to speak a little bit about our research in the physiology of work and exercise response laboratory to give you all a little bit of information about the Institute of Exercise Physiology and Rehabilitation Science. So I'm the co-director of the Power Lab with Jeffrey Stout. What we do is we focus on applied exercise physiology and exercise science. And because we are sort of on this applied side, we tend to have sort of varied interests in different areas of focus. So you can see the research capabilities there, quite broad, allows us to focus on a number of different questions, which helps us to support our sort of primary mission of mentoring students and developing master's and doctoral level researchers. I'm going to go through a couple of our studies that we focused on recently, but I just wanted to highlight a couple of pieces within the research capabilities here that I might not talk about throughout the various projects we have ongoing now. So body composition assessment is one of the big ones that we sort of an area that we've focused on a lot in the past, and we have quite a few capabilities ranging from being able to set up different component models for body composition, with the first one being just being able to differentiate between fat mass and fat. But if we can go through and we quantify body water, it helps us dial things in a little bit more. And then if we can quantify mineral through bone and that sort of thing, we can combine the different measures from our instruments to be able to get a broader picture of body composition assessment. The other piece that I probably won't get into much for the rest of the slides is the skeletal muscle form and function. So we tend to focus on non-invasive assessment of muscle through a number of different means. One is ultrasound, where we're able to take a picture of the muscle, be able to characterize the size, and then do some grayscale analysis to look at some of the makeup of the actual muscle. One of our prior projects was actually examining the ability to capture these images of muscle and then comparing it to other ways to evaluate. So one is through Tensomyography that I'll talk about in a couple of slides, but also through the application of bioelectrical impedance analysis through something kind of termed electrical impedance myography. So looking at reactance and resistance and the phase angle characteristic that you can quantify between the two of those to evaluate muscle. So I took the opportunity to put together the slides, actually sort of check my own areas of specialty to see if what I have posted on our website and through Google Scholar sort of match up with some of the other databases that are out there. So I looked at Publon's, Web of Science, and Scopus to see if they sort of matched up with the specialty areas that I had listed specifically involving assessment, performance assessment, exercise physiology, and they tended to come up pretty close with the Publon's ones there and listed in alphabetical order, but exercise physiology, human movement and sports science, and then a little bit of the nutrition, and it tends to be mirrored with the other two. I will point out just a couple of things with this. My own interest in martial arts is something that when I get an opportunity to study it, I do, but I grew up doing judo and wrestling. Has a special place in my heart. So whenever I can do research related to it, I try to. One of the projects that I didn't include in the next couple of slides is actually working with another colleague in health sciences, working on developing judo programs for children with autism to see what sort of potential benefits there are, both through physical activity and social emotional sort of development there. So it's been a great series of projects that we're still continuing, and it's a nice way to blend a number of different areas of interest and look at areas for collaboration. So I just pulled together some of our recent publications and some of those that are in review, and then some ongoing projects. So this first area here is sports science. That first example there, one of the examples of when I get an opportunity to examine some judo related questions. And it's some of the stuff that I do here is with international colleagues. It's pulling in some pre-existing data from the International Judo Federation, looking at the age of sort of peak performance. There's several studies out there looking at that for centimeters, grams, and seconds type sports, but with judo, it's not so simple to sort of look and see where people are performing at their top level. So we did want to sort of quantify what age people tended to be represented at the World Championships and Olympic Games. Not quite analytics there, but sort of on the edge of it. And other previous publications in a similar vein, we're looking at time motion analysis and ways that we can evaluate what happens during competition and use it to inform training. These next 3 papers under that sports science category are examples of projects that were developed through our UCF Athletic Sports Science Initiative, working with athletes on campus, trying to implement a number of different projects. One looking at different ways, different warm-up type techniques, and seeing how that might affect the muscle and then overall performance thereafter. So a couple of the videos you can see there off to the side. This is an example of tensomyography, which uses electrical stimulation to provide a local contraction of the muscle. And then that transducer that's placed on the muscle belly will give us a time displacement curve. And we can pull out various parameters that are related to sort of passive muscle function. And then that last example there, working with some inertial measurement unit data from the volleyball team, specifically looking at female collegiate volleyball athletes, because on an international level, there's a broader focus on male volleyball, but in the United States, we have very strong women's collegiate volleyball athletes. So this is sort of an observational study. The other sort of big focus is on exercise metabolism. We have, we have that standard capability to look at aerobic capacity and VO2 max test, but we tend to broaden it out a little bit so we can look at different ways to sort of model the exercise or the physiological response to exercise. So one of the ways that we try to do that is looking through oxygen consumption, both during exercise and then the response when exercise is no longer being conducted. So we use some modeling procedures to look at how the oxygen response sort of declines over time, and that gives us an idea of different energy systems. And this last one is actually looking at upper and lower body cycling, sort of comparisons in metabolic responses. And I just wanted to highlight this one a little bit because it's part of the reason why I'm particularly interested in upper body exercise is because of that original interest in grappling and judo that has a larger upper body component than a lot of other sports. So we're trying to find different ways to characterize this. So this is actually focused more on the health side of things, looking at people who may have limited mobility, wheelchair bound, those kinds of things, and seeing if there's ways that we might be able to inform exercise prescription. I guess I didn't point out that there's other picture here is looking at a hypoxic tent. So we do have this hypoxic generator that we've used in a number of different studies, just to, as a way to augment training to vary up the physiological stress that occurs during exercise. And a few more areas here. Resistance exercise, strength and conditioning is a big part of what we do. One of the more interesting studies that we've done recently was trying to look at different training paradigms. So a typical way that people train would be like 4 sets of 10 of whatever exercise they may be doing with sort of extended rest in between. And what a number of researchers are starting to do now is try to look at these smaller sets. So they call them cluster sets, where maybe we would do 10 sets of 4 with shorter rest periods. So can't really see it probably all that well, but down in the open and closed circles here, these open circles tend to go down. This is mean velocity during the actual movement for the exercise for the 10 sets of 4. And then the dark or closed circles here are during the 4 sets of 10. Actually, I just said that backwards. Pardon me. The 10 sets of 4 are the dark circles, and the 4 sets of 10 are the lighter circles. And the reason why we're looking at that is to try to determine if people are training in a requisite manner for what their performance outcomes are. And a lot of the performance intentions for people is to enhance power or explosiveness. And if we train at slower velocities, we may not be as effective as we could be otherwise. So general takeaway of that is if we can break these sets up into smaller numbers of repetitions, we might be able to maintain velocity over a training session. We're applying similar methods, looking at sort of force velocity or low velocity profiles in a number of different ways, particularly looking at the ROTC actually here on campus in relation to their Army Combat Fitness test. Dietary supplementation, I don't think I mentioned earlier, but a big part of the way that our lab is funded is through small industry-based grants. And these two particular examples are looking at caffeine containing either energy drinks or multi-ingredient supplements and evaluation of the autonomic nervous system and then cognitive function. And then this last piece I'll just hit on briefly is we do have a doc student now who's interested in circadian variation and chronotypes. And so we're on the front end of a number of different projects looking at how that may be impacted by different exercise routines. So we took the advantage of COVID from last summer and tried to get an idea of if self-reported questionnaires for chronotype were impacted by shifts in daily routines. And we did find that there was sort of a shift from evening type and morning type to intermediate type for most people. And then we're going to follow up with a number of different exercise evaluations at different times of day and see how those might be impacted. Just a quick note here that I've had current or previous collaborative efforts with people in New Orleans College. So Dr. Park has allowed me to take part in an ongoing project looking at rowing and motor learning, and also to be involved with the thesis. And Dr. Wu and Dr. Taylor from CCIE, who've worked on a couple projects and grants, looking at how to incorporate a number of biometric signals into sort of different ways to evaluate children's responses to play therapy. And then the last piece was an opportunity to serve on a dissertation committee in industrial engineering. And that was pretty eye-opening to me to see how much overlap there was between our different programs. This last one is just a quick plug for the Institute of Exercise Physiology and Rehab Science. I mentioned the capabilities that we have in our labs. There's a number of labs that have similar capabilities, and a bunch of great researchers involved with the Institute, ranging from projects like I mentioned here, but also even within kinesiology, we do have a wet lab space, so we have ability to evaluate blood markers, saliva, that type of thing with Dr. Wells. So if you all are interested in collaborating at some point, there's a large group of researchers involved through the School of Kinesiology and Physical Therapy. Just wanted to say thank you to our grad students and the co-director of my lab, Dr. Stout, for all their efforts in supporting my work over the years. And thanks for the opportunity to share some of the stuff we've been working on.